Hello, everyone. I'm Dr. Wang. Here is the question. If x, y, and z are real numbers, we want to solve this nonlinear system of two equations for x, y, and z. It's a challenging question. We have two equations containing three variables. The two equations are nonlinear. First of all, we define two new variables. From the first given equation, we define the inside part of this square root. X plus y minus 2 equals u. Z squared minus 8z plus 14 equals v. Using the second definition, v equals z squared minus 8z plus 14, we rewrite v as z squared minus 8z plus 16 minus 2, because 14 equals 16 minus 2. This equation is true. Why are we doing this? We want to make a perfect square for z terms. Therefore, z squared minus 8z plus 16 equals z minus 4 squared. Z minus 4 squared is always bigger than or equal to 0. Therefore, v is always bigger than or equal to negative 2. This is the very important result. From the first given condition, we replace x plus y minus 2 by u, z squared minus 8z plus 14 by v. Solve this equation for x plus y. X plus y equals u plus 2. From this equation, we apply this condition. We have u plus 1 equals negative v times square root of u. Negative v is less than or equal to positive 2. Then we have this result. U plus 1 is less than or equal to 2 times square root of u. Move this to the left-hand side, we have this inequality. How to solve this inequality? The left-hand side is a complete square, which is square root of u minus 1 squared, less than or equal to 0. But square root of u minus 1 squared is always bigger than or equal to 0. Combining the two conditions, we have square root of u minus 1 equals 0. This implies u equals 1. This is the given first condition. And here, both sides minus 2, we have this result. This is u, this is v, this is u. Then we have u plus v times square root of u equals negative 1. U equals 1. We replace u by 1. We have 1 plus v equals negative 1. Therefore, v equals negative 2. U equals 1. What is the definition for u? X plus y minus 2 equals 1. From this equation, we have x equals 3 minus y. Because v equals negative 2. This is the definition of v. Therefore, we have z squared minus 8z plus 16 equals 0. Solve this equation. The left-hand side is z minus 4 squared. Therefore, z equals 4. This is the 7th given condition. 2x minus 5y plus square root of xy plus z equals 3. We replace x by 3 minus y here and here, and z by 4. We have this equation. This equation only contains one single variable, which is y. We want to solve this equation. Simplify this equation first. Square root of 3y times y plus 4 equals minus 3 times 3 plus 1. How to solve this equation? We need to get rid of the root sign first. How? Taking squares on both sides. Be careful. When you are taking squares on both sides of an equation, we may have possible extra solutions for y. Therefore, when we find y values, we have to come back to check if y is an extra solution. Squaring both sides, we have 3 minus y times y plus 4 equals 9 times y squared plus 2y plus 1. Simplify this equation, we have 10y squared plus 15y plus 5 equals 0. Factoring the left-hand side, we have 2y plus 1 times y plus 1 equals 0. Therefore, we have two solutions for y. Y equals negative 1/2 and y equals negative 1. Because x equals 3 minus y, we replace y by negative 1/2 and negative 1. We have two x values, 7/2 and 4. Therefore, we have two possible solutions for this nonlinear system. X, y, z equals 7/2, negative 1/2, 4, and 4, negative 1, and 4. We have to go back to check these two possible solutions if they are real solutions from this given two equations. By checking, the only solution is the second one. The first one is not. You can check it. That's all. Thanks for watching, and see you next time.